Welcome to the Old Okie Workshop. I'm Richard. Here's the full explanation of how the assembly table goes from normally rolling to stationary. There's a gang of bungee cords right here, and the purpose of these bungee cords is the same on both ends because they're the other end is connected up just like this end, okay? There's a fishing line right here. This piece of fishing line goes underneath this and it attaches to this screw. Okay, so when this when you pick the assembly table up, this hits the floor. Then we want it to swing into position when we pick the thing up further, right? And so gravity is going to hold it right here, straight up and down. And therefore, we need this to swing over into its final position, which is at an angle. And that's what the bungee cord is all about. So you can see it move as this leg goes down. Remember, down is this way, right? Okay. So as the leg goes down, get it in its final position, boom, bungee cord does that. And the same thing is true the other end. In the normally rolling position for the assembly table, these legs are up off the floor, hidden underneath this shelf, and this lever is in this position. And the legs are held up by two things. First of all, this lever actually goes over the top, I guess it would be the bottom of this leg as well as that one to keep them from coming down. But what really holds it up is the fact that there is a line attached here on this lever. It goes through a screw eye right here, and then it is attached to a screw on the leg right here. So as this line is pulled that way by this lever, this leg is pulled, up like that. And the same thing is true on the other end, but this one has a spring. And there's a screw eye right down here, and this line is connected through the screw eye to a screw on this guy right here. So when we first start to put this down, this lever moves like that. These start to come down. Okay, so they're coming down, coming down, coming down like this. And then this one has done the same thing. Okay, and then we know the gang of bungee is going to make this go into the final position, and this is how we position this lever. Now when it's time to put them up, things get more complicated. Now I want to put the assembly table back to the rolling position, which means these legs have got to come up into here, right? So the first thing I'm going to do is take this lever and move it from the legs down position toward the legs up position, but not all the way. So there is a spring here that's providing tension, pulling this lever this way. Now this leg cannot move, okay, and this line is long, and this line over here though is right now, this is tight. This line is tight, but the leg isn't moving because it's on the floor. So I have this clamp on here to clamp the leg down so that it can't move. Now I'm going to pick this end of the assembly table up, and when I do, that's going to release this leg off the floor. So it can then, because of the spring, it's going to move into this position like this. Okay, and it's going to go to about right there, and that's all the further it's going to go, because the other end, but I'm going to go ahead and let it down now, all right, but it's going to stay right here, but it's up off the floor. Now the other end is still on the floor, so when I come and pick it up off the floor, then it is going to move as well because of the tension in this spring pulling the lever. So here we go, it's moving, moving, moving. Comes to about this position like this. Oh, sounds like a little birdie has joined us. That was actually a northern mockingbird. What do you think of that? Anyway, this is now moved into, it's actually going to be in this position, right? These are going to be about like this. Now it comes time to move the lever. So the lever is, the spring has been pulling the lever so far. Now I'm going to move the lever into this position like this. And when I do, this line becomes tight and keeps this up, and then this line becomes tight. It's even tighter than tight though because of this spring. Okay, now there's a reason why there's a spring in here. Consider what happens if the lines on this lever are connected at the same distance from this fulcrum and they are of the same length. Okay, so then when this starts to move and I want to pick up this end of the assembly table and therefore this line is taut, then that line is as well because they're the same length. So when I pick this guy up, guess what happens? Nothing, because since the lines are the same length and this end is still on the floor, this won't move, so this won't move. And what that means is this line here has got to be shorter so that when this gets in this position and this end is picked up, then this can begin to move without being held by that one. So it can move into this position about right here, which is up off the floor. Now I can go to the other end and pick it up, and when I do that, it gets released from the floor and this moves the rest of the way. Now what that means is that these lines need to be of different lengths, and since this is a fulcrum like this lever, they have to also be placed at different distances from this fulcrum in order to make this whole thing work, because that line is going to have to be about twice as long as this line. For this end to move first, okay, then this line has got to be shorter than that line over there. So when this guy is pulled to this position just up off the floor, you can see over here there's slack in this line, and that doesn't start to pull for a while until you get, actually, where is it? Right here is where that starts to pull. Now you can see that this angle is this way off of right straight across, and the reason for that is because when this line travels from this position over to this position, its final position, it goes from here to here. That's the chord of a circle, and the circle has its center right here. But when it's traveling there, it actually travels on the arc of the circle, and the arc of the circle is longer than the chord of the circle. So this thing will not wind up being halfway across, right here, when this guy is still down on the floor. So that's a problem. And then if this line, when it finally travels all the way and it's taut, if this guy isn't the right length and at the right place on here, that won't make it because this is shorter and it'll just stop right here. So it turns out that this point right here is about 12 inches from the fulcrum, and that's about 18. And that ratio worked out pretty well for the lengths of the strings I've got. But it's still, when I got this to the end, this guy was still holding on to it, and I couldn't get this all the way into the final position, and that's what the spring is all about. So the spring allows me to pull this cord completely tight to have this up where it should be, all right, and then the tension in the spring here does the same thing here and allows a little bit of flexibility, a little bit of play in this where this finally has to wind up. So that's a complicated explanation, but in your case, you're going to have to do a lot of experimenting to figure out how to get these things exactly in the right place. Also, this spring here is a little bit of a problem. The further you pull it, the greater tension, right? Because it's stretching. But if you put it on an angle like this, it pulls a great deal here, and then as it comes around this way, it starts to pull less and less. So that's how come this is at an angle like it is. All right, so that's the full-blown explanation of how this whole thing works. It was a lot of fun to build. Here's how it works. Pull this lever this way, legs come down, put it in the locked down position, pick up the end, legs swing into place. Thanks to the gang of bungee cords, it goes into place. Now it's time to put it back down on the rollers, move this to the middle position, pick this end up, legs go up, this end, same thing, and now back into the lock position, presto, rolling again. And that's the long, complicated version of how to make the assembly table go from rolling to stationary. Thanks for watching.